Okay, this is section 12.4 of the notes dealing with angle measures and segment lines. The first two theorems that we have are finding angles that are not central angles and are not inscribed angles. So they're not in the middle of a circle and they're not on the outside. So what we have here is if we have an angle that's formed by two lines that are on the inside of a circle, I'm going to use this formula right here. So the two lines that make up angle 1, I just highlighted in green, and then the arcs that go with that angle 1 is going to be this angle x right there. And then if I had a vertical angle that this would be 1 as well, then I would know that the other corresponding arc would be y. So what I can do is use those two arcs that go with the angle and the vertical angle, and I can add them together and then cut them in half. So with this, whenever I have two lines intersecting, the angle happening inside a circle, I'm going to add together my arcs that correspond with it and then cut it in half. The second one is kind of the same thing. So if an angle is formed on the outside of a circle, I'm going to use this second formula right here. The only difference is I'm going to subtract. So when I know outside, I know subtract. And so again, if I highlight the lines that make the angle's on the outside. So there's my angle, it's on the outside. And then the two arcs that are made from this are going to be arc X and arc Y. And so the way that I do this is that this X, this first, is always going to be the arc that is far away. The second arc is going to be the arc that is near. So I'll take the far arc, subtract the near arc, and then divide it by 2 or cut it in half. So when I'm doing these problems, with the first one that we have on the left-hand side, again, my angle is happening inside my circle, so I know I'm going to add my arcs together. So x is equal to 1/2 of 90 plus 46. So when I do that, I can add together 90 and 46 and get 136. And then divide it by 2, and I get 68. Going to do the one over on the right-hand side then. Again, my angle's happening outside of my arc, of my circle. So if it's outside, I know I'm going to subtract the far arc from the near arc. So x is equal to 1/2, and then the far arc is 72, and the near arc is 22. It should always give us a positive number there. So when I do that, I get 72 minus 22 is 50. Half of 50 is going to be 25 then. With the second one, this is one where I kind of have to work backwards a little bit. So again, my angle's happening outside of my circle, so I'm going to write a note that says outside. I know that the angle is equal to, so 20 is equal to 1/2, and then I'm doing far arc, which is 95, minus z. The easiest way to do this is to multiply both sides by 2. When I do that, the 2 and the 1/2 cancel each other out. And on the left-hand side, I get 40. So 40 is equal to 95 minus z. And so what I can do is I can add this z over to the other side. Get z plus 40 is equal to 95. And then subtract the 40 to get z is equal to 55. And then the last example, the third example that we have here, again, is another one where I have to work backwards. So again, this is an inside of the circle. So I go 35 is equal to 1/2, and then x plus 30. So again, I'm going to multiply both sides by 2 to get rid of the 1/2 so I don't have to distribute, like a shortcut. 70 is equal to x plus 30. Subtract the 30 to the other side, and I get x is equal to 40. With a problem like this, again, I can just choose which variable I want to solve for first. First one I'm going to do is x. I'm going to highlight the lines that make x. X is an inside the circle angle, so I know I'm going to add the arcs together. So when I do that, the two arcs that go with x, again, is going to be this big angle that I highlighted in green, which is 180 degrees. and then again the vertical angle with x. Oops, let's do it in red. And the arc that goes with that x that I just drew in was this little arc. Again, I know that this half of the circle is going to be 180 degrees as well, so I know that this arc is going to be 50 degrees, because 60 plus 50 plus 70 equals 180. So when I do that, again, I'm going to go x is equal to 1/2, and then I'm going to add together my arcs, 180 plus 50. So again, I can multiply both sides by 2. Oops, nope, not going to do that. Just going to plug that into my calculator to get x is equal to 115. There we go. And with the second, to find out what y is, I'm going to erase my work here. To figure out what y is, again, I'm going to have to use this 53-degree angle because that's the two lines that make up this arc y. And then the other arc that makes up from those two green lines is going to be the big blue arc that I just drew, which is going to be 180 degrees. The 53-degree angle is one that's going to be on the outside. So I'm going to go 53 is equal to 1/2, and then again it's far arc, which is 180, minus the near arc, which is y. Again, multiply by 2 to get rid of that 1/2. I get 106 is equal to 180 minus y. And again, I can add this y to the other side, then subtract the 106 over to the other side to get y is equal to 74. So the entire front side of the notes, those first 2 slides or 3 slides that we went through there, we're all dealing with angles. The back side of the notes, and from here on out, we'll be talking about line segments. So the easiest way to kind of go about this is we've got 2 different cases here. We've got case 1, we've got case 2, and we've got case 3. These are just kind of formulas that I can use. So when I look at the first example here, this example A on the left-hand side, the first thing that I want to do is figure out which one it looks like. So since I know that both of these lines go all the way through a circle to the opposite side, it's going to look just like case 2. So I know that this one's going to be a case 2. So I'm going to write a little Roman numeral 2. Oops. And I'm going to use the formula here. And so what the formula basically says is I'm going to take the piece on the outside, and that's going to go on the outside of my parentheses. So it's going to be 6 parentheses. And then on the inside of my parentheses, I'm going to add together the outside plus the inside. So that's all with that top line. With the bottom line, again, it's going to be the outside on the outside of the parentheses. And then on the inside, I do the outside plus the inside. So what I can do is I can multiply these together. So 6 times 14 gets me 84 on the left-hand side. I can distribute the 7 and get 49 plus 7y. If I subtract the 49 to the other side, I get 35 is equal to 7y. And then divide both sides by 7, so y is equal to 5. With the second example here that we have, this example B right here, again, I've got a tangent line and a line that goes all the way through to the other side of a circle, so that's going to be a case 3, a tangent line and a line that goes all the way through. And so when I do that, again, I'm going to use the same formula. That formula says that I take that tangent line, and I square it. And then on the other side with this line that goes all the way through, again, I'm going to do the same thing. Piece on the outside of the parentheses, and then on the inside, the outside plus the inside. So I get z squared is equal to 192. And then take the square root of both sides to get z is equal to 13.86. The third example that we have here, the lowercase b, again, I've got 2 lines that are both inside of a circle. And so since they're inside, it's going to be a case 1 where I have 2 lines inside of a circle. So when I do this one, again, I'm going to use the formula, which is just multiplying both pieces of the line. So if I multiply the two pieces of my horizontal line, I get 6.5 times 3, times m. And then with the other line, the vertical line, 3 and 7, then I can multiply 7 times 3. So I get 6.5m is equal to 21. 21 divided by 6.5 gives me m is equal to 3.23. And then the very last one is another case 2. Oops, I should have put this one's a 1. And this one is a 3. Just a little reminder. This last one then is another case 2. So when I write my equations, it's going to be 14 times 14 plus 20 is equal to 16 parentheses 16 plus x. So on the left-hand side, I get 476 is equal to, when I distribute this 16, I get 256 plus 16x. When I subtract the 256 to the other side, I get 220 is equal to 16x. Divide by 16, and I get x is equal to 13.75. And the last two that we have here, again, I just want to figure out which variable I'm solving for and then write an equation. So if I'm solving for y, I've got y, and then the easiest way is to do the 15 and the 7. Remember, I can only write an equation with one variable. So if I'm solving for y, again, that's a case 3, where I'm going to take that tangent line and square it. So y squared is equal to, and then of that line with 7 and 5, it's 7 parentheses 7 plus 15. So I get y squared is equal to 154, and then I can take the square root of both sides to get y is equal to 12.41. Then to write an equation and solve for x, again, I want to use line x and 5, because I need to solve using the line that has x in it, and then I can use this 15 and 7 because I have already used it before. So I can go 5 parentheses 5 plus x is equal to 7 parentheses 7 plus 15. So I get 25 plus 5x is equal to, and then 7 times 7 plus 15 gives me 154. Subtract that 25 to get 129. Divide by 5 to get, 25.8. And then the last example, the one that I wanted to solve for, was z, because it's a little bit different. So if I'm solving for z right here, I'm going to use this line z and then this other line that I've highlighted in green. So again, that's going to be solving for z. That's going to be a case 3, where I've got a tangent line. So I'm going to go z squared is equal to, and then I'm going to do 6 parentheses 6 plus, and then I just got to fill in the blank there. Again, that second number always has to be the inside length that I just drew right there, which in this case is going to be 9 plus 6, which is 15. And so that 15 has to go in there. Whoops. So I get 6 plus 15. So I get z squared is equal to 126, and then take the square root of both sides to get z is equal to 11.22.